Now that you've created the conic in Sketch, we can try and create the conic in the 3D environment in the shape design workbench. So let me try and do this. Before I go into creating this conic using the two guide curves, let's create some wireframe and create a line. And we'll do point to point, and I'll just randomly create a point on a plane. We're going to do all these on the YZ plane. I'll just kind of shoot something over here, insert a point on the YZ plane, shoot something over here. For this example, it might be easier to switch into the front view. So I can see what I'm doing here. I'll select OK. And we'll create another line, create a point on the YZ plane, something like this. On the YZ plane again. The two lines have to be eventually they would intersect somewhere. And the goal is to try and connect the two. Again, if I go line to line, it's not a smooth transition between these lines. So that wouldn't really work out too good. I can go into, where's this? Conic. And select the YZ plane. And select this point as a start. And select this point as an end. And I'm doing that because that's what it's asking me in the pop-up window. So I got the vertex lines, line 1 and 2, this 2 points here, where start and the end as it says here. Tangent, remember how we picked the line that was tangent to this line? Well, this creates that projection on the parallelogram, and this one here creates the projection on the parallelogram, and it defaults to a parabola. Okay, so there's your parameter of 0.5. And there's your conic. That'd be the same thing I just did in the sketch. When I say OK, there's your end result. Let's go and do this again. This support on the YZ plane at this point, and then the ends over here, and then the start tangent has got to go to the first, and then the end is to the second, and parameter value of 0.25. Same thing I did in my sketch. One more time, parameter support is the YZ. Select this point, select this point. There's your start line tangent, start line tangent on the second part. Let's do a parameter of 75. So that would be up here, and a parameter of 100 wouldn't work. It has to be something greater than 0 and less than 100. Select OK. All right. Ellipse, hyperbola, ellipse, parabola, hyperbola are the 3 different kinds of conics I created. Again, that generates the smoothest transition I can from one line to the next. I'm going to pop into the ISO view. And we're going to go to a sweep surface. And I'm going to use line with reference surface. Select this line in my YZ plane. An angle of 90 degrees. Let's just go 5 inches long. Preview that. Ugh, that seems kind of long for the size I have. Let's just go 2 inches. All right, so there's a line and projecting it, extruding it, is you have a linear surface. Basically, any way I cut this, it's a flat line, or it's a straight line. Any way I split it, any intersection I create to it, you have a line as the end result. That makes it a segment, line, or linear type surface. Alright, so it's the same thing I did in 2D, it's just that it's three-dimensional now. And I'll do the same thing on the other end using this line. So again, there's your line and there's your sweep. And then we'll select preview, select OK. So I could actually just take that and sweep it as well, since I already have a conic. If you didn't have that generated and you just had the surfaces, what you could do, and most commonly would do, is go right to the conic command and use two guide curves. Guide curve number 1 would be this curve here. That's that boundary that represents that point on that line. And then it's going to be tangent to this surface right here. So in the pop-up window, I've established the boundary curve on the top and the tangency, and it's going to ask for the end. Remember, this was the start, this was the end. So in this case, instead of the point being the end, this line is the end. And now ask for the tangency. This is the surface, or what the line was that it was tangent to. So it's very similar, and again, it defaults to a 0.5 parameter. I select OK, and there you have it. This surface here is your parabola. Again, you're generating the smoothest surface you can possibly create, the best, smoothest transition I can make using conical surfaces from one end to the next. Let's say you had something underneath this and this was hitting it, so you actually need to create something further up. That's when you just simply create a different parameter value. I'll do this 2 more times. So this case here, it was this guide curve, this surface, this guide curve and this surface, and then we will do a parameter of 75. I'll color that just so you can see it. I picked almost this identical colors here. How about dark purple? Okay, so there's your parabola inside, hyperbola on the outside, and the very inside one. Maybe there was something up here and this was bulging too much and hitting it. So if there's something on top and you need to get it to shorten, you could go back to sweep, conic, guide curve, that guide curve, that surface, this guide curve, this surface, parameter value of 2.5. Select OK. There you have that surface on the inside. Alright, so hopefully you can see the correlation between creating a conic in the sketch versus a 2D wireframe, and also three-dimensional surface of your conical surfaces. Try that out and we'll do the next demo with 3 guide curves.